In this video lecture, we'll be solving this problem, minimum number of increments on subarrays to form a target array, which is a Leetcode hard problem. In this problem, we're given an integer array target and we have an integer array initial of the same size as target with all elements initially 0. So we have two arrays. One array is target and another array is initial. Both of these arrays have the same size and both of them are integer arrays. Initial array contains all elements as zeros. Now I define some operations on the initial array. In one operation, you can choose any subarray from the initial array and increment each value by 1 in that subarray. Fine, that's the definition of one operation. We have to return the minimum number of operations to form a target array from the given initial array. Fine, the test cases are generated so that the answer fits in a 32-bit integer. So the integers in the array does not exceed the 32-bit integer range. So in the input, we will be given the target array of size n containing n integers, while in the output we have to return a single integer representing the minimum number of operations required to create that target array from the initial array. Let's see the constraints of the problem. The length of the target array or the initial array may go up to 10 raised to the power 5, while the value in target array may go up to 10 raised to the power 5. So let's better understand the problem statement using an example. So here we have our target array. So this example has been taken from the problem statement itself. So in the problems, in the input we are given this target array. The size of this target array is 5, and we want to generate this target array starting from the initials array. So this is my initial array containing 5 zeros, and I want to convert this initial array into the target array. And what type of operations we can perform? We can pick any subarray for this initial array and increment the value of each element in that subarray by 1. Fine. So in the very first operation, I take the entire array and increment the value of each element by 1, giving me an array of 1, 1, 1, 1. So giving me this array. Then I choose the subarray starting from the second element till the second last element, and I increment the value of each element in this subarray by 1, which will give me a final subarray of 1. So this is because you can see that I first had 1 here. This is because I can see that each element in this array the first operation was to choose the entire subarray. Then in the third test case, you can see that I have integer 3 in the final subarray. I have to perform one operation on this subarray containing exactly one integer, and that is element number, while giving me the final array as 1, 2, 3, 2, 5. So this is the final array, and this is same as the target array required. So how many operations I took to reach the final array or the target array? 1, 2, and 3. Hence the answer for this test case is 3. I require 3 operations to arrive at the target array starting from the initial array. So what I did was, I had this target array, I observed that all the elements in this target array are at least 1. So you can see that we have no 0 element in this array. So I performed the operation on that's why I performed the operation on the entire array, giving me all the elements as non-zero. Then I can see that I have second element, third element, and fourth element greater than 1, 2, 3, 2. So I can perform one operation over this subarray. That's why I performed second operation over the subarray starting from the second element till the second last element, giving me a subarray of 1, 2, 2, 2, 1. Then I observed that the third element in this subarray is 3, and here in our array the third element is 2. So I picked third element here and I performed one more operation to make it 3, and this resulted into our final target array, while the number of operations are 3, and I guarantee that these are the minimum number of operations. How can I solve this problem? In the input we are just given this target array and we have to return this integer 3. Fine, so let's build the intuition for this problem. So this is my initial array. I want this array from this initial array. Fine. So one of the tempting approaches to solve this problem is simply start from the very first element of this initial array. So just simulate the process as it is given. So one of the tempting ways to solve this problem is to just simulate the process which I explained in the previous slide. That is, start with this actual initial array containing all elements as 0, then iterate over the target array. So I start from the very first element, it is 1, and in my initial array I increment the first element by 1, then I move to the second element and I see 2 here, and here we have 0, then I increment this to 1 as well, then I move to the third integer which is 3, and here I see 0 and 0 is less than 3, so I increment it by 1, then I move to the next integer which is 2, and then I increment it by 1 again, then I move to the next integer which is 1, and here it is 0, so I increment this by 1 again. Fine. So this was the first iteration. Then I come back and I start from the first element again for both of these arrays, and I see that the first elements are matching, so I move to the next element which is 1 here. So 1 is lesser than 2, so I increment. So this is the array which I get after performing exactly one operation, that is to choose the entire array, and increment the values by 1. Then I again start from the first element of the target array and from the first element of the initial array, and I compare the elements again. So I see that the first element of this initial array matches with the first element of the target array, so I move to the next element. Then I move to the second element of the initial array and I compare it with the second element of the target array, and I see that second element of the initial array is less than the second element of the target array, so I increment the value here by 1 till this. So here I have chosen my sub array from the second element. Then I move to the third element which is 3, and here I see that 1 is less than 3, so I increment this 1 by 1, giving me 2 here. Then I move to the next element which is 1 here, and here I compare it with this 2. 1 is less than 2, so I increment this by 1. Finally I move to the last element and compare it with the last element of the target array. They are same, so I do not have to include this element into my sub array, so I break the loop right here. So whenever I end my sub array, I have to break the loop right there. So I again check this is not my final target array, and the operations has become 2. Then I again iterate over my parent array and compare the results and compare the elements. I see that the first element is matching with the first element of the target array, the second element is also matching, the third element is not matching, so I increment the third element by 1, and now it is matching, so I have started my sub array here. Then I check the fourth elements which are matching. Since they are matching, I have to break the loop right here and copy the remaining array as it is. So then I compare this array with the target array, and they are same, while the operations increases by 1. So now I have arrived at my target array after performing 1 plus 1 plus 1, exactly 3 operations, and that's the answer. But how many iterations that I had to perform over my initial array? 3 iterations. It is equal to the maximum element in this array. Which is equal to the maximum element which is present in this target array, which is 3 here. So the maximum element may go up to 10 raised to the power 5, and in each iteration I have to compare the current array with the target array, which may have up to 10 raised to the power 5 element, giving me 10 raised to the power 10 time complexity, which is costing me 100 seconds, because in 1 second I may have 10 raised to the power 8 iterations, which is not an optimal solution. It will not work for the constraints given in the problem statement. So I have to improve upon this very tempting and naive approach. Let's see the better solution for that. So let's try to build a better solution for this problem. Instead of moving from the initial array to the final array, just think in the reverse direction. How many operations it may have taken to arrive at this target array? Fine. So I first go to the very first element and I see 1 here. So if the first element is 1, that means at least one operation has been performed over the initial array, because initial array contains zeros. Fine. Then I move to the next integer, which is 2, and I see that this 2 is greater than the previous element, which is 1, by 1. That means the difference between the second element and the first element is 1. That means I have to perform exactly one more operation starting from the second element or on the second element than I performed on the first element. So if I performed, let's say, x operations on the first element, then I have to perform x plus 1 operations over the second element, because in the first element I had 1, and after I perform one operation I would have my array as 1 1 1 1 1. So this would have been my array after I perform exactly one operation. But then I check the second element. It is 2. So the second element has to be 2. That means I have to perform one more operation for the subarray starting from the second element. I don't know the ending point, but the subarray starts from the second element. So that's why I take one more operation. Then I move to the third element, which is 3. It is greater than the second element by 1. That means after I have performed two operations over the initial array, when I move to the third element, then I have to perform one more operation starting from the third element to make up this target array. Because after two operations, the array would have been 1, 2. Since the third element is 3 in the target array, that means I have to perform one more operation which includes this third element. So I add 1. Fine. Then I move to the fourth element and I see 2 here, which is less than the previous element. So I do not need to perform any operation over here. Then I move to the final element, which is 1, which is again less than the previous element. Again, I do not have to perform any extra operation, while and giving me answer of 1 plus 1 plus 1 as. So that's how I solve this problem. Rather than thinking from the initial array to the target array, I think in reverse direction, that is check how many operations we require to generate the target array. So the logic for this problem is simple. I just have to keep track of the previous element. Initially this previous element is the first element, and then I iterate over the array starting from the second element till the last element. And all I have to do is to check if the current element on which I am standing, that is target I, if this is greater than the previous element. If it is the case, then operations will be increased by the difference between this target element and this previous element, that is target. So that's how the answer will be updated. After that, update the previous variable to the current element. That is, for the third element, the previous variable would be this second element. Then I again take the difference, and so on. Finally, this answer variable will contain our answer, and this is initialized to 1 initially. So let's see the implementation of the approach which I explained here. So this is the min number operations function which takes in the target array, initialize an answer variable with the first element of the target array and a previous variable with the first element of the target array, compute the length of the target array, iterate over the target array starting from the second element till the last element. And here I am checking if the current element is greater than the previous element. If it is the case, then store the difference between the current element and the previous element into my answer. Add it to the answer, while update the previous variable to the current integer on which I am standing. Finally, return the answer at the end of this min operations function, because this will contain the final number of operations required to convert the initial array into this target array. Fine. So that's how this function is working. Let's see the time and space complexity for this implementation. So you can see that the time complexity for the given implementation is big of n because I'm iterating over all the elements exactly once, and the space complexity for the given implementation is constant because I'm not using any extra space. So this is a simple approach to solve this problem. There is another approach to solve this problem, that is using monotonic stack. So how we can solve this problem using a stack? How? Let's see that. What I can do is, instead of using a previous variable, I take a stack data structure, I initialize it with 0, and then I start iterating this array from the first element. And I check if the top of the stack or the element at the top of the stack is less than the element on which I am standing, because all I want to find is the difference of the adjacent integers. So that's all the target for this problem. So I'm assuming that we have 0 here. Then I want the difference of these adjacent integers if the integer x is greater than its previous integer. Fine. So that's the idea. So I assume a hypothetical index here which contains 0, and I push this 0 into this stack. Then I start from the first element of the array and I take their difference. The difference is 1 minus 0, that is 1, and I push this 1 into this stack. So I have 1 here. Then I move to the second element, which is 2, and I check. Then I again see that the current element is greater than the element at the top of the stack, which is 1. So 2 minus 1 is 1. This is again added to the final answer, and I push this 2 into the stack. Then I move to the third integer, which is 3. 3 is again greater than 2. So I again take the difference and add it into the answer and push 3 into the stack. Then I move to the next integer, which is 2. Here 2 is less than 3, which is at the top of the stack. So what do we do here? So since 2 is less than 3, that means I do not need to perform any operation over this subarray starting from this 2. So in that case, I keep popping these elements till the elements in this stack are greater than the elements on which I'm standing. So I pop 3 out of the stack. Now I have 2 here. So here I check, I see that the 2 is less than 3, which is at the top of the stack. In this case, I do not have to perform any operation starting from this 2 because the element on the top of the stack is already greater than this element. So I keep popping the element from this stack till it is greater than the current element. So I pop 3 out of this stack. Then I push the current element into the stack. So I push 2 into this. Then I move to the next integer, which is 1. And I check if this 1 is greater than the element on the top of the stack. And it is not the case. So I keep popping the elements out of the stack till they are greater than this 1. So I pop this 2 out. Then I again pop this 2 out. Fine. And then I push this 1 into the stack. And that's how I end my. And the answer for this would become, the answer for this is, which is my final answer for this test. And that's how I use a stack to solve this problem. So the job of the previous variable in the previous approach is replaced by the stack here. Fine. So let's see the implementation for the approach explained here. So this is the min number operations function, which takes in this target array. I declare a stack, initialize it with 0, initialize the count with 0, which is the final answer. Then I iterate over the target array and I check if the current element in the target array is greater than the element on the top of the stack. If it is the case, then I add the difference of these two integers to my count variable. Then I pop all those elements out of the stack which are greater than the current element because we no longer require them. Then I push the current element into the stack. Finally, I return my count variable right from here because this will store the answer. So this is how the min operation function is working using the stack data structure. Let's see the time and space complexity for this implementation. We can see that we are iterating over the target array exactly once. The time complexity becomes linear, that is big O of n, and the space complexity is also linear because here I'm using a stack data structure which is a linear data. Fine. So that's the time and space complexity. Let's jump to the implementation part. So this is a solution class which contains this min number operations function which takes in the target array, and then I calculate the size of the target array. I initialize two variables, previous variable and answer variable, with the first element of the array. Then I iterate over the array, target array, starting from the second element till the last element, and I check if the current element is greater than the previous element. If it is the case, then I add the difference to the answer while updating the previous variable to the current integer on which I'm standing. Finally, I'm returning answer at the end of this function. So this is how the function is working, and this is the implementation in C++. This is the implementation in other languages. So this is the implementation in Java, and this is the implementation in Python language. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to my YouTube channel and give your feedback in the comments below. I'll see you on the next video. Till then, take care. Bye bye.